All right, so if you remember, and we discussed a important pattern called singular pattern, but I hope you also remember the name I gave it. It's called interview pattern. Okay, a lot of you found it useful. It's actually, you can find a lot of this usage in different SDKs and libraries. Normally, the entry point of the library will be depending on that one or two classes, and using singleton is always easier to manage. Same time, as I told you, it's a perfect question to ask during the interviews. All right, so let's do a very quick test and quiz here. Okay, so I'm actually sending a link right here. Could everyone open it? And it's a repo link, and you don't need to use your ID. Just use that repo. It's fine. It's more like an interview. Okay, so you don't have to run it. Well, you can run it, but let's assume that this is your interview. All right, and then I give you this class here. Now, could you turn this class into a singleton class by applying the singleton pattern? Okay, so if you open this repo link, I think if you modify it, it will actually make a copy on your own, and you should be able to directly write your code there. It doesn't conflict with others. Okay, so if you open this one here, and then if you type anything, it's gonna, it will just make a copy on your own, and then you get your link. All right, so give it a try, and then if you finish, could you send that link back to me in the chat window so that I have some ideas on how fast you can do it and how well it is. Yes, so turn this class into a singleton class. So for those of you who just joined, all right, I'm sending you this link. It's a quick in-class exercise, or you can call it a quiz. Try to open it and then turn that database manager class into a singleton class. Just directly code it or code a singleton class. Once it's done, send that URL back to the chat window so that I know. You can also send it just to me directly. All right, so let me send it again for those who just joined. All right, so right here. Okay, so here's a link. Again, if you just join, open that link and turn that class into a singleton class. Once you're done, send the link to me as soon as you can, okay? Because, think about this, the interview, you don't want to keep the interviewer waiting too long. I think this question, ideally, you just finish that within 1 minute. That's going to be looking really good. All right, I saw a couple of you just join. Open this link right here. I sent in the chat window. It's an in-class exercise. Turn that class into a singleton class and then send the link back to me. All right, okay, looks like Wes already got it. So I'm gonna stop sharing and you take a look at some of these answers. Perfect. All right. Yeah, good job, Wes. You're definitely hired. Okay. And then it is right. Yeah, very good. Let me see Jason here. All right. So Jason, yours actually missing a couple of things. All right, yours works, but Yeah, it works, but it's not the ideal solution. Okay, we talk about three important points, and you use a static field, but there are actually two other things. Double check that. You can take a look at web solution, and then you probably will figure it out. All right, let me take a look at runs. All right. Yeah, Ryan, yours still like first of all, let's not use that Boolean flag variable. We talked about that. You can just get rid of it. And then secondly, you don't really need to put anything in the private constructor because whatever you put, it won't be executed. Oh, I take it back. It will execute it. But then more importantly, the static fields to store the instance shouldn't be public. Because if it's public, then people can always modify it. And yeah, and also we talk about something called a lazy instantiation. Think about that. So there are a few things to improve. All right. Let me see Catherine solution here. All right. So Catherine, two comments. Number one, think about how do you take care of the lazy instantiation, and then also you're missing a very important part. Catherine, double check your solution, because with your solution we can still create new instances if we want. We do the new statement. All right. Checking Nick's solution here. All right. Pretty good. Yeah. Well, Nick, the only thing I'm not too sure is, are you able to do in Java? Does this thing work? Nick, I'm sending this in your chat window. Okay. Does this thing here work in Java? Can Java check things like this? No.
Oh yeah, I should probably use just checking for null.
Right. It might not work. Okay. I never wrote that way, but then try it. Okay. It probably doesn't work. Yeah, it doesn't. It doesn't. I just tested in Eclipse. It won't work. Other than that, everything looks good. All right. So let me just check a few others. Anthony. All right. Looks like very good. Yeah, Anthony, yours is perfect. You are hired. And then Ryan, this is a different one. Let's see. Yeah. So Ryan, yours is the same. You're missing an important part. Okay, so we still can instantiate new instances. And let me take a look at Nick's solution here. Okay, Nick, yours is good. All right, you are hired as well. Let's see, Rush. All right, okay, I got it. So get pointer here. Rush, yours is, there's actually a compile issue. You won't be able to see that in REPL, but they're very minor thing. Okay, check your line number 21. And Andrew, let me see. All right, Andrew, I think yours is good. Okay. Oh wait, why do you call it a singleton class? You know what? I'm gonna share my screen from now. Okay, since a lot of you already submitted. So Andrew, take a look at my screen. Why are you naming the class as singleton? That doesn't make sense. All right. So this one is wrong. Try to fix it. Anything else? All right, I'll take a look at maybe 3 or more submissions here. This is Vice solution and private. Yeah, this is not right. So first of all, you're missing the way to prevent people from creating new instance. Secondly, you make this one just private public. A might not work. Okay, let's double check this part. And let me see ins solution here. Yeah, a very minor compile error. Okay, similar to a rush problem, I think. Double check your line number 8. Okay. And then let me see. Payton. Yeah, Payton, same error. Line number 9, I think your code is not gonna compile, okay? Same error as in Ricky. Take a look. Yeah, I think Ricky, yours is perfect. All right, good job. And then let me see, David. Yeah, looks perfect. Good job, David. And then Jason again. Yeah, so Jason still needs something, line number 6, double check. And Christian. All right, perfect. Good job, Christian. And this is Milan. All right, good job. Well, even with synchronized version. All right, nice. All right, and then Aaron, let me see. Okay, looks good. This one, there is no need to declare this again. Just directly assign DB is fine, right? So, but other than not big issue. Okay, very good. All right, and then let me see, Chelsea here. All right, perfect. Good job, Chelsea. And then Amanda, let's see here. Amanda, I think you're missing one thing, right? This part is good, but there is one more thing missing, and so that people can still accrue the instance if you want, right? All right, and let me see, Catherine's again. Let me see here. All right. So Catherine, yours, double check yours. Okay, Catherine, I think there are two minor issue. Line number 11, some issue here. Line number, yeah, it's not quite right. Okay, see, this code here, you put it here, then who's gonna call it? All right, we're gonna instantiate it. Okay, so double check that, Catherine. All right. All right, and this is good. All right. Oh my, this is good. All right, and then let me see. All right, so I'll take a look at like two or three more. Okay, so it's getting better now. Actually, let me see here. All right, good job. This is perfect, Ashley. All right, and then in phone rule, let me see here. All right, this is also pretty good. And in one, let me see. Nice. Okay, good job. And synchronized version. And Catherine. All right, looks good. All right, okay, guys. I think I'm gonna stop here. Okay, so let me go through this one very quick. Pretty straightforward. Earlier, I think Wes did the perfect submission. Okay, he was the first one, and pretty impressive. All right, so you can find some other answers from some of the submissions, but I will just go through the answer here. Okay, remember, turning any kind of class into singleton, you only need three simple steps. Okay, first of all, don't forget that we need to make sure that the constructor is private. Okay, that's the most important one, because if you don't have this one, people can always go to create a new instance as they want by using the new statement. All right, so all we do this one first. If you do this one, nobody can actually create a new instance by using a new statement. However, we still need to get an instance, and the solution will be we need to track and keep one copy of the instance inside the class, and then we do that by using a static field. All right, for static field, and then it's going to be a type of itself. All right, so normally we call this one as instance. All right, this is a better name. Last time I was using a name called a pointer, which is also fun, but instance probably is better. We're talking about specifically one instance. All right, so if this is static, then it's good that I can just use that one without using any of the object, right? But then to make this one safe, it's good to keep it private. Otherwise, people can always change it and access it. It's not very good, as we talked before. Now, if this one is private, and then you will need a getter to do it. Okay, so because otherwise nobody can access it. So you need a public getter. So you want to say get instance. All right, and then here you have to return the instance. However, if this instance has not been instantiated yet, and then you will need to do it. Right, instance equals to new database manager. All right, and then this return type is database manager. All right, and then there are so many of you actually made a mistake. I pointed out that this method right now is not right. It's not going to compile because you're trying to use a static field in a non-static method. This method is not static, which is not going to work. All right, if you want to do this one, oh, sorry, I take it back. This one works. The other way won't. Okay, if you do a static method, but then try to use a non-static field, that won't work. But but then this one here still is not right, because you're trying to return this one here, and then you must make this one as a static. That way, people can just call this method directly without creating a concrete instance. They will just call this one, and that will actually return the instance. If the instance has not been instantiated, then we'll just create one. So this keyword, so many of you actually miss that. All right. So that's one other problem. So really, we're looking at three things: private constructor, and private static field, and finally public static getter. And then you better to do a lazy instantiation inside the method here so that you don't have to always create instance at the top, because some of this instantiation process might take a long time. All right, so any questions about this one? Let me see. Yeah, some of you missed the private constructor, and then I see the biggest issue is that static keyword. Okay. All right. So very important, guys. As you can see, this question, if you are very familiar with it, it really takes you about 30 seconds to 60 seconds to finish. And for the interviewer, it's very easy to check. I can just pick it in 3 seconds. I know if you're right or wrong. So perfect case to ask during interviews. Some other patterns won't be that easy. All right, so that's why this one is number one asked design pattern question during interviews. All right, very important, guys. You might have a chance of getting this question at some point. Especially, I would say some of the smaller company, they might ask you. If it's just a software engineer, they ask you this, talk to you, very likely. Big company probably won't. They just stick with the algorithm questions. All right, so that's what we covered last time. All right, so today let's take a look at one more pattern. Okay, and this is called composite pattern. All right, let me keep this one here. All right, so this is going to be the second pattern we discussed. Okay, very practical. It's also being widely used in different kind of libraries. So let's take a look at the motivation of this pattern and what kind of problem we're trying to solve. So we try to compose the object into the tree structures, all right, to represent porthole hierarchies. So we're trying to build some kind of hierarchies, and then looks like it's kind of like a tree. And but this, again, these are too vague. Without seeing the example, we don't know what's going on. So another intent is the individual and compositions of object are all treated uniformly. It sounds like some kind of individual stuff and composition stuff are treated in the same way. So what does that mean? And where do we apply that? To represent the whole part hierarchy of objects, to allow clients to ignore the difference between composition and individual object. So it sounds like this is a lot about individual and composition, whole part type of thing. All right. Pretty hard to understand based on this description, but just have some kind of high level idea there first. So let's take a look at concrete example, then you will find how they works. All right, so this example is going to come from this book, the Gundam 4 book, the design pattern book. In that book, if you read it, most of the examples were based on this kind of a UI application. Because that book was written in the 90s, and 90s was when all the programmers started to make UI application using Windows type of applications. Okay, they started to build all this cool widgets, and then to make something more visual. And at that time, programming those applications were considered to be one of the most challenging applications to do. Right? Very difficult. If you see, I never coded it by myself. In the early days, if you try to program like a window using some of these Windows frameworks, just create a window and show it and a button to confirm it. It takes hundreds of lines of code to write it in C or C++. Very difficult, or mostly in C. And you need to use a lot of pointers, handlers, a lot of this very weird concept. I touched that briefly when I was in college. was very difficult. Okay, so you can imagine that if you build a very complicated UI, how much more code you need to write. Just one window, and also it's a very error prone. Think about today, if you ever build a mobile app, that is just causing you 1 or 2 lines of code, and then you're never going to have any kind of errors just to adjust the UI. But in the past, this one definitely was very difficult. A lot of lower level stuff, and then you need to control a lot of rendering, graphics, all these details. All right. So here's the situation now. Let's say we are building a kind of a UI application, and whenever you build a UI application, you will need to use some kind of widgets, and such as buttons, most commonly one, input box or text area, text edit, depending on what kind of framework you're using. They may have different names. You might have some images. You might have some kind of menus. A menu has menu items. All right. So these are some of the typical widgets. Also, you might have some kind of containers. So for example, we need to group some of those together. So just like a layout, just like maybe just in HTML, we have something called a division. Or in just some of the UI, we can even call them at window or form or panel. If for those of you who have done some Java Swing development, you know, there's J panel, you know, J window. I don't know if there's J window, but I know J panel probably is a container. So those kind of concept, those widgets don't have much visual content, but then they can be used to group and contain other widgets, right? So we're talking about how are you going to form a kind of a good hierarchy for this kind of UI system in terms of the widgets. What are the classes we need to use, and then how do we organize their relationship? So that's what this pattern is trying to solve. So there are a lot of slides. I realize that it's kind of better to skip some of the slides. Let me just show you some code so that you have better understanding about everything. All right. So I'm gonna go back to my Eclipse. So I will create a second pattern here. I'll call this Composite Pattern. All right, so in this demo application, I'm going to create a package. I'll do a version 1. All right, so we'll see how we can improve that. So we're talking about making some widget classes for the UI system. Okay, so let's start to make something very simple, and then later on you will see some of the ideas I have. Okay, so I'm going to start with the button. And so, you know, once you have a button class, you can set something to like a on click or something like that. I'll just mark some of the method. Okay, on click. All right, we'll just do something. But very importantly, we also have something maybe to render it. Okay, so I will say something called a render button. Okay, so I will print something. The button is rendered with the text. All right, just a message to simulate it's being rendered. All right, so very simple simulation of the button. It doesn't do much, but then you know there's some behavior. There are also some ways you can like refresh and display the button. And I'm going to create the next one. Next one will be the text area. Okay, text area. I can't remember which one used. Maybe Java Swing used text area. In Android, we use edit text. In different UI, we use different things. Okay, so to render the text area, we also need to show something, right? We'll say that show text area. All right, so showing the text area. Okay, and in the text area, you can have some of the classes like the text, and maybe you will get a getter and setter. I just want to show you that in every class, there is some of the specific things about this class, but also a very importantly, you need to have a way to display that, to show it. I'm going to call it show text area. All right, whenever you want to render and show it, you need to call this method. All right, so let's do more. I will do something called maybe yeah, we'll do a menu, right? Menu bar. All right, so the menu bar has, maybe we need to specify the position. Position Y. Where do we put the menu bar? All right, put some getter and setters. And obviously there's a lot of things you can do with it, but I'll just put something really simple. And just like the other widgets, we need to show it, render it. Okay, so I will call it maybe I'll just call it set and display. Okay, this way. Set and display the menu bar. All right. As you can see, all this looks very, very similar. Okay, this one is for button, this one is for menu bar, this one for text area. And I'll just do one more, okay, just to show you there are tons of stuff you can do. Maybe a image, okay. I'll call it like a 2D image. Oh, you can't do the 2 like that. Image 2D, okay. All right, so image 2D, we need to just show it. Okay, I'll maybe set image URL. And then this one we'll say like um, render image with URL. Okay, download the image and render. All right, and then here we will do a getter and setter. Okay, so I'm gonna do this for typing widget. Hopefully you can build something with a button, with text area, and then put the image, put the menu, and give you some very basic UI system. All right. So these classes share something in common. So they're all called like individual widget. Okay, very easy to understand. So you build a system, you can drag and drop some of these buttons, you can use as many as you want, but every button is an individual entity. Every image is an individual entity as well. And then same for the menu bar and text area. Menu bar, maybe you can say you can have a lot of others, but let's right now assume that menu bar is just one thing that you can specify a lot of titles, everything inside it. So let's assume it is one entity, okay? However, we also have some containers. Now you build the UI, you can't just directly show a button or show a menu or show something. You need to put them somewhere, right? Like in a window, a panel, a form, right? So I will just do something called a window. I will create a class called a window. All right, a window, very important, and I need to basically just create a window and then we'll be able to also to show and display the window, or maybe open the window, right? So I'll call something called open window. And then this one is going to basically opening the window and display all the widgets included. All right, for window, we might have some of the properties like size and everything, but the more importantly, for window, we need to know what are the things we're including. For a window, I can have some buttons, I can put some images, I can put the menu bars, I can put anything. Any of these types can be included in the window. So in that way, this is how you need to create a window. So I need to basically create some potential list of buttons. Right? I will need to create a potential list of image 2D object. I'll call it images. I will need to create a list of menu bar. And also a list of text area. You might not need it, but at least you can have those. All right. So let's do a getter and setter for all of this. All right. And then also we can do a constructor if you want. And let's see. Yeah, I'll just use the getter and setter. Okay, so that will be easy. So if you have this, and when you are trying to open the window, okay, so we need to display all of them, right? So when you are rendering the button, you need to go to the button to render it. So one way we can do is to say, okay, if the buttons doesn't equal to null, that means we got something here, right? So I'm gonna use a for loop to iterate it. Every single button, assume you already configured them. I'm gonna call something called render button. That's the method we have. Okay, so render button. In the same way, if your images doesn't equal to null, and for each image 2D, and then we're going to use the image called set image, not set URL, sorry. We need to do render image with URL so that we can render them. And then we'll do the same thing for menu bars. For each loop, menu bar. Right? And now, does anyone still remember the menu bar method? It's called set and display. And finally, we got a text area. All right, so this one is called show text area. All right, so pretty straightforward, guys, right? So because the window is a special one, it's a container, so it can contain all of this. So when you're trying to open the window, and then you will actually need to take care of all of them if you have, right? If you don't have it, then nothing to worry about. And then they will each take care of themselves because they will know how to render the button, they will know how to render the image and download the URL, all of this. Okay, so now we're done with the system. Now to apply this system, we're gonna create a class called UI driver. And that's where we have our main method. Okay, I'm gonna create my thing. Okay, so I'm gonna have a button here. And then button one, what do we have? Like we don't have anything. All right, so let's just leave it here. I may create two buttons, one for okay, one for cancel. I need a URL image. And then let me see what I can do here. Can I do set? Yeah, I'll set some image URL. All right. And then we have a one menu bar. What do we have for this? Set position. All right. Finally, we want to have maybe two text area. All right. So what's wrong with this? Oh, get. Sorry, I said get. So it should be set. Okay. So these are all the things I want to have for my window. Okay, so I'm going to create my window. Okay, app window. But this time we need to set everything. Okay, I need to set all the buttons. We need to put them into a list, right? So there should be some, I don't know if you guys know some of the simple ways to turn things into a list. You can use something called arrays dot as list, and then you can create a new array, and then I will turn that array into a list. So I'm gonna do a button one, button two, okay? Has anyone used this one before? So arrays is a built-in utility class that can turn, there's a lot of good useful methods, including sorting, toString, but at this, it can take any kind of array into a list automatically. This is how I create an array in real time, I don't need to specify the size. I can just put two object into a bracket, and that's going to give me an array. Okay, so that's just a very quick way for you to create some kind of a list. All right, so app window, set images, arrays dot as list, new image 2D, and then I got my image. All right, two more lines, we're done. Menu bar, arrays as list, new menu bar. Finally, text area, arrays as list, new text area, 1 and 2. Okay, finally. All right, so to run this, all I need to call is app window dot open window. All right, so if everything works perfectly, it's going to iterate all of these things one by one with the order and then show everything, right? So let's try it. So run this application as a Java application. All right, so opening the window and display all the widgets. So the button is rendered, download image, render it, set display the menu bar, and showing the text area, So perfect solution. All right, we're done. Okay, so I spent a little bit more than 10 minutes to code all of this. It's a very naive UI system with different widget class and a container class, and that's how you use it. All right, so any questions so far about this piece of code? Now, as I'm writing this, obviously you guys already saw a lot of places to improve, right? What's the number one biggest issue you see so far about the way I code? The one thing you want to improve most? No interface, but what's the problem, Rash? What is the issue? What is the part that's not very convenient or flexible to change? Oh, right. The goal is to simulate a way for you to build a like a UI system. For example, you want to build a UI application, and then you just create all this widget and then put them into a window, and then you open the window, you can run your UI. So that's the goal, to simulate all the structures. Repeated work, yeah, adding new widgets, very good. So as I mentioned, whenever we're talking about the design, good or bad, we look at the changes. If this one is working, if this is the version you want, then there's nothing wrong with it. But then what if later on we need to add another type of widget, right? And I see a lot of you did solve the problem. Some of you mentioned about interface, some of you mentioned about abstract class. I can see clearly you guys solved the problem. All right, the problem now is, the root issue is it's not really unified. One thing you can see, I don't know if you noticed, this thing here is called render button, and this one here is called render image with URL. This one here is called set and display, and then finally is called show at text area. So I'm gonna support a new widget. Okay, now I got a new one. I'll just do one more time. This one will be like a reading bar. Okay, so this is a name I know from Android. So you can like type a reading 1, 2, 3, 4, 5. Okay, so you got a reading here, but you also need to show it, right? So I will call this one, if this is added by a new developer, the new developer will call it, run reading bar. Okay, so somehow he did this name. But all he's trying to do is to show the reading bar and start to receive the readings. All right, so he added this one. And now the window method need to make some changes. So here we'll need a reading bar. Okay. Oh, reading bar. All right. However, you also need to get to here to say if the rating bar doesn't equal to null, and then we're gonna iterate this whole thing. Okay. Run rating bar. So that's how I finish the extension. However, this time, as you see, I jump into this existing method to make some modifications. This is not called open close, following the open close principle, because you actually going inside this method to add something. Even you're adding at the end, this is very bad because I told you, number one, you just don't know how complex this is in reality. And there's no guarantee you always just attach something at the end. You probably need to go into inside. Then the downside number two is what if we want to delete it? Well, you still have to go back here to delete all this code, and then here, here, here. So it's very bad modification. Now we want a simple extension. Just add something there in a very separated location. We're done with the change. But then obviously this kind of design isn't supported. Now, to follow all of your ideas, guys, if you see it, we need interface, and then we need some kind or an abstract class. The thing we really want to unify is this, right? Can you see it? Button is called like a render button. Image is called a render image. With URL, this menu bar is called a set and display. And then this one is called a show text area. And finally, this one is called run reading bar. Okay, very bad. Okay, it's all different name, but they're trying to do the same thing, which is to render them. Okay, so very good. A lot of you already mentioned that. Okay, let's do that. All right, so I'm gonna create, let me see if I can copy this whole thing, okay? I'll do the second version here, okay? I'm separating them, guys. Okay, so this one is all the version 1, and we're in version 2 now, okay? So this time to adapt some of your suggestions, I'm gonna create an interface. I will call this a standard name called a widget, perfect name for the UI system. And let's put one method only. As I mentioned, I'm trying to unify this stuff. Okay, button, you got render button, and this one you got render image with URL. Very bad. Okay, so I will just create something called render. Really simple, concise, and tell you the purpose. All right. So with this, I'm gonna start apply all of this. This one is gonna implement widget. All right. Now it really is complaining because this one should be called render, not render button. So I'm going to do that. All right, so that fixed the problem. So I'm going to do this one for one by one. Image should be a widget. Apply the interface, and then we need to change this one into something called render. All right. Menu bar should be a widget, and then we need to change this one to be render. Reading bar is also a widget. This one should be called as render. All right, and then text area is also a widget. And then this one should be called render. And okay, so now if these are being updated, now I go to window. All right, so you can see this part here is going to become so much easier and cleaner. Okay, so take a look at what is the code looks like right now. Okay, 5 different attributes and then 5 different for loops iterate and 10 getter and setters. But with the interface we have so far, this is how we're gonna do it. All right, so I'm gonna get rid of all of those. I'm only gonna keep one thing, which is called widget. All right, and then this one which is simply called widgets. And I don't need anything else. This one will be a widgets. All right, and then this one here will be also a widget. and then this one will be called render, and then we're done. So I don't need this, 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 and this anymore. Now I don't need all of this getter and setters. And now I just need to add one more getter like this. All right. Okay, so this is an improved window. All right, now to apply this one, you don't need much changes. All I need to do, guys, is to place everything here together. Okay, so this is what I'm gonna do. App window dot set widget. I still use this erasing, right? And then new widget. I will just place all of them inside. Here, image 2D, menu bar, text area 1, text area 2. Okay, throw them all together. It doesn't matter because they're all widgets. Finally, running the window. All right, you got the same result, right? And obviously, you can see the code got much shorter. It's cleaner. But if this point, if you still want to add a new widget, that's okay. It's really not difficult, right? So we'll do another one. We'll do something like what other widget we know. So we'll do a checkbox. All right, so checkbox is a type of widgets. And then we need to implement a method called render. Rendering checkbox. All right, so that's it. All right, so I only create a new class in totally separate places. I don't have modifier change anything else. This one thing here works as well. If you just want to add another checkbox, go ahead. So I'll take checkbox. And then just place somewhere here, okay? And to use that, that's it. Now we'll run our code. All right, so there is the checkbox. Okay, so this is kind of the baseline for this project. It's already a big improvement. Now, hopefully, by following this kind of a code, I actually spent 20 to 30 minutes already. You can see the improvement if you use interface correctly, right? In many cases, this is not really an extreme example. In many cases, when you program classes in the beginning, you probably never thought about interface. And then, when I was naming this one, I intentionally try to use different names. However, in reality, you guys all programmed this before. This one happens all the time. Sometimes, for example, when you create something to load the data, you will probably start something with like a read data, read list. Later on, you call another class. You create another class. You call something called fetch, and then you create another class, and then you realize you need to do something similar, and for some reason you just call it retrieve. All right, so that's always a situation that in the beginning you didn't realize it, and then one point you should really think about how do you unify them. However, for better designers, they can probably see that from the first place. They will start to build the interface. All right. So sorry for widget. Jason, what's your question? Widget is just the interface. Yeah. And then, yeah, I'll push the code to GitHub. So this is the interface, so all the others can, apply. All right. So, but this is, we haven't really touched the composite pattern yet. Okay. For the composite pattern, we're talking about another thing. Okay. So now you can see this part of the things here are widget, and then window is a kind of, a kind of a container. And then there are a lot of containers you can build. All right, so let's continue with this example. Let's say that I want to do another thing, which is um, so I'll make something called my like a high level another kind of a container. Okay, we'll talk make this situation a little bit more complicated. So we got a window, and what could be contained the window? Okay. Oh, you know what? I'm gonna call it screen. Okay, screen maybe a like a bigger. Uh, I'll call it app screen. Okay. So app screen is a higher level container. Okay, it could contain windows. It could also contain widgets. All right. Think about you're building the app. So in order to do this, I'll follow exactly the same thing. Okay, I can do a window. I can also do a bunch of widgets. All right. So this is like a super level, like a UI thing. Okay, you can do, and we can put some getter and setters. All right. And then for here, I'm going to create a method called for app. Okay, this is maybe quite a totally different thing. I'll just say that, start screen, app screen. Okay, when you start, you will do a lot of things, and then part of the thing is actually to kind of iterate, like uh, to iterate all the stuff and then render them. Okay, same way. Okay, I'll need to do another one. So like Windows here, if that one doesn't equal to now, and then I'll do window. Window will be something called open window. And if the widget isn't equal to now, then we'll just do widget. And then we'll call them to render. Okay, that's the thing we just built. All right, so that's just another kind of I'm trying to build another complicated container that could contain the windows. All right, so that's how we, in general in the UI system think about that. If you build any kind of web or mobile, always you got some containers, you got some individuals. That's what the pattern we're trying to talk about. When you have this kind of container and individuals, the way we're building so far here is actually pretty good, pretty clean. Okay. And this one can contain others, but you can also add this widget directly to the screen. There's nothing wrong with it. You don't have to, sometimes you don't have to, put them all into the windows. Let's assume that's what we're trying to support. All right. So that's kind of the situation we're talking about here. Now, let's go back to the slides a little bit, okay, to see what they're trying to tell us. All right. So, we are building this, and how does this window manage different items, and the widgets are different from containers, right? So there's a kind of a situation we have. So we're going to deal with all of them individually. Like this is what we're building right now with all the different widgets and the container and all of those. And then we will have a method called update, and in my case, called open window, or you can call it like a run app screen. That's going to iterate everything, okay? Iterate everything, all of those, and then where's this hierarchy? That's what we have so far, okay? So they got a widget, different widget, and they got a container and a different kind of container, okay? So this one looks pretty good, okay, pretty good, but it's still not perfect. There's still some room for us to further improve it. Okay, that's the thing we're going to talk about. All right, because now obviously you are treating the container and the individual like widget differently. Okay, this one is fine, but is there a possibility that we can even like merge them? Okay, get them also into the same time. Now, if we can, how are we going to, to program it? So that's what this pattern is trying to tell us. So let's actually follow some of the slides, and then we'll come back to that code. All right. So we can also encapsulate the composite and also the simple object behind a common interface. All right. So again, let me clarify. Previously, we got an interface for individual widgets, but then the container is not included. And then the question here is, are we able to include the container as well and put them under one type of interface? If that's the case, then what the interface will look like? All right. This one here gave us a solution example. Let's assume that you're trying to build some kind of a graphics engine. You're trying to render some of the specific lines, rectangle, different shapes. And then these are some of the basic element you're gonna basically render. Like you can do line, you can do rectangle, you can text, basic fundamentals. And then you call them draw. And then you build the interface called graphic, the draw method. Okay, that's pretty easy, very easy to understand. But you have something called a picture. Now the picture could contain all the other types. All right, it's a container. The picture doesn't have itself doesn't have anything. You must provide all the line, rectangle, text to the picture. All right. However, I also want to put the picture under the same like interface, because for picture I also need to render it, to draw it. So it's fine to just do it. And then if you put it here, then the picture will have a very good like advantage, which means that the picture could contain everything about the graphics. So there could be association from here to here. Let me see if there is a better example, not here. So that you can see there is a good advantage about a picture that you can do both, the picture could contain both this kind of individual widget and also another picture itself. All right. So let's actually look at the standard pattern design. Okay, I don't think the slide order is perfect. Okay, let's forget about this kind of picture example. Not very good. This is what the composite pattern is. Very concise. Okay, this is the ultimate solution you want to learn today. So we have something called a composite. We have something called a leaf. Leaf means widgets. Composite means that windows we created. The window can create other things. However, don't forget the window can also contain other windows. Okay, so if you have these two things, you could actually think about putting them together under the same interface. All right, so they will share that same operation, but more importantly, if you do this one, you will allow this composite to go back to contain other components. And to really treat them at the same type. And then if you can build this, you will have, you could have a lot of advantages about doing it. But then if you do this one, you need to make sure that the composite could have a list of widget. And then you start to see a lot of benefits. Okay, so this one, hopefully you got the big picture. Okay, let's actually look at the code. Then you actually see some of the why we're thinking about this one, what is the big deal about doing this. Okay, so I'm gonna leave this version here. Okay, I'll create one more version. I'll call it version 3. All right. So version 3, we still have all of it. We start with this. Now there's a widget interface. Keep in mind now the widget only has buttons, checkbox, image, menu bar, rating bar, text editors, 5 and 6 of them included. All right, they're all individual, we call the leaves. All right, now what we want to do is we also want to put some of the containers to be the same type. And then we can take a look at what's the benefit of doing that. So right now the container window is not a widget because we saw this is the container. But according to the pattern, you could mark them to be the same one. So I'm going to implement this widget. And then once you do this, it's not going to work because we require a render method, right? So that's fine. This is basically what we're doing for the render. Okay. So I'm going to do this. All right. So once you put this, as you can see, nothing really changed. And the only thing is now your window also become a widget. So what's the big deal about that? So if you make that one happen, so first of all, let's fix this one. Okay, this one should be like a render. All right. Now, if you do this, first of all, when you go to like a window, it's really easy because you really don't need to worry about anything. And then you can basically render anything as long as they can render themselves. You just throw them into a list, and then you can just go through this one by one and then do that. As I mentioned, because the window also become a widget, so you can basically also put a window inside, right? So if I go back to the driver, let's say that I create another window. Now this is app window, like a, you know, pop-up. Right? And I'm not going to render it for now, but I create another one, app window, you know, main. All right, another window. Now this window is going to include the other window. So set widget arrays dot add a list and a new widget. So this one is going to include the app window pop-up. So this window is going to contain the other window, which is fine, right? So in most UI systems, your layout can contain another layout. The division can contain another division. You can have multiple levels. That's fine. Or if you still want another new widget together, so you can put them here. So I'll call it checkbox 2. And I can use that one. Plus, I want to do another checkbox 2. Okay, and then from here, I can do app window main dot render. All right, so if I run this code, obviously, it's going to render the whole first window first, right? It's going to render all the first windows. And then so this is open the main window. And then from here, we're going to open the pop-up window. All of this is done. We're going to open that checkbox. All right. So I don't know if you guys see the real benefits of doing this. We are now unifying the individuals and the composite or containers, so that the containers can deal with any of the children without knowing its type. It really doesn't matter. You gave me window, I'm going to render the window. You gave me individual, I'm going to render the individual. Right? It's really convenient. Also, back to this one here, I was trying to build, this example, I now realize it's a little bit confusing, but you don't really need to have this kind of a thing, okay? Because your app screen, you just need something to show. It doesn't really matter. You're just going to provide a widget. Okay, you don't need to differentiate that window. This is totally not necessary. Okay, you start the screen, just render everything. All right. So, but this is just actual example. I show you how to use this hierarchy. You're using everything just like a widget. By doing this one, it gave you a really good flexibility, guys. Now think about, I want to add another container. For example, this container is for graphics only. So that means I only can do like image or, button, this kind of thing. I don't want to do text. So I'll do a graphical canvas. Let's put it this way. Maybe this one have some kind of improved performance in terms of rendering. All right. So this one here, I'm going to implement it as also a widget. For this one, and it can contain a list of widgets as well. All right. if you the ones you put it here will all be like optimized. Okay, I'll call this one optimizing the graphics rendering. Right. So you're adding a new kind of container. But that's it. You're not gonna mess up all the other classes. And then if you want to use this one, go ahead and use it. So I go back to my UI driver. I'm creating another, for example, this is another, I call it a graphical canvas. Right? And then graphical canvas can also set, oh, I didn't do the getter and setter. All right, it can also set the widget. This time, I will just only place the ones with image and all right, so I'm adding this one here. And then if you want to apply this one also to the window, that's okay. Just store them here. That's fine. Or if you want to put this one into another window, it's all fine. It's very flexible, as you can see, because everything is just a widget. You never need to worry about what is that image. It's okay because everybody knows how to deal with that rendering process, and that's all you need. Okay, let me run this again. That's how it works. All right, so this is kind of a very quick overview about this composite pattern. So I'm going to push the code, okay, to GitHub, and then so that you can review it. But then keep in mind, I want to show you this process. You can see how we can improve that step by step. This version 2 is already a big improvement, and then version 3 is really talking about could we merge the individual and the container together, and if we do it, what's the benefit? As you can see from here, the biggest benefit is it's very easy to program anything new, to process anything, because everything is just a widget. And they all know how to render themselves. You don't need to differentiate the type. You don't need how to create different references to store them differently. Everything has been simplified. All right. Yeah, so Rafi, back to your question, yeah, you need to, if you want to prevent that one, you need to just add some extra logic. All right, so you might want to have some kind of the better way is you have something called add widget. So we'll talk about that one from the pattern. The pattern actually gave you this method called add widget. So that way, you can check the type, okay, from here. If the widget type is not a certain type, then you're going to throw some exception. So that's the one way you can do it, right? So in the pattern, it actually specifies something like this to tell you you need to add some kind of add method, remove method, something to deal with the children, right? So that's how we do it. But there are some trade-offs about this design. So we'll go through that next time. For example, should we actually, right now I'm not really putting this method here in the parent class, which we could. Okay, if we do that one, it can simplify a lot of this. However, at the same time, it will mess up this part. So there is a trade-off. It's not a perfect solution, but depending on what we're trying to do here. Yeah. But in all these classes, you can feel free to extend and add your new logic to do something different about validation or something else. But the key idea is to merge them into the same kind of hierarchy. Yes, so Ryan, back to your question. So a composite class is made of the individual component as well as another composite element. Okay, so that's the key idea. So composite contains, let me see this one, yeah. Composite, as you can see, it contains a list of component. It's not contains a list of leaves. This is very critical because if this one contains a list of component, that means it can contain leaf, it can also contain component. All right, that's how you can do this kind of hierarchy. Think about in the UI application, if you're a builder, you often have a root. Now the root could directly contain some widget, but it can also have some kind of group or container panel. That panel can contain something else. You can build this level as many as you want. All right. But this design give you that perfect organization. Did you see that? Really easy and clean to do that. All right. So this is a really nice thing about the design pattern. So it's a very simple idea here. If you understand it well, you can capture the really the value of it. It's called a composite pattern. Are you asking that, Ryan? Yeah, this design is called a composite pattern. Right. Okay, so I went through the code. Okay, next time we'll do some more a summary about some of the benefits of the pattern, and then something like this. So very practical. Okay, if you ever use like an Android UI, look at the classes. Okay, I'll show you one example very quick. If you go to Android, something called a view. A lot of you done Android development before. Okay, view is the root level widget. So everything in Android UI is called a view. Okay, but then the view could have a lot of like a container type of thing or non-container. So it can have, for example, a text view. It's kind of view. It's a widget, but it can also contain layout, like absolute layout. There's a containers. Okay, so almost every UI system is built with this kind of approach. All right. Okay, guys, I will see you on Thursday. Okay, so we'll wrap up this pattern next time.